Hi. Looks like we've got a couple of people here, and we're going to go ahead and start. You should be able to see a Q&A on the side here, and you can ask questions there, and I will be able to, while I can't hear you, I will be able to answer your questions there. What we're going to do is, since a couple of people had some problems with the link yesterday, so we're going to go ahead and do some of this review again. And if you have questions, be sure to type them in there on the side. If you're having any trouble, you can also text me at 414-899-8269, and I should be able to get you set out there. Just going to share this with you here. There you go. And you should be able to see that. What we're going to do is go over some of the key topics that I think are important for you to know for this. And I want to start at the top, as always, which are the key development activities in the software engineering process that we've talked about. Because remember, what we've done this semester is we've tried to show that the software engineering activities are all part of supporting So I always like to be able to remember the 4+1 view, because it shows how important use cases are to the central process of not only eliciting requirements, but then creating a domain model, understanding the role of boundary, entity, and controller type objects, and then starting to think about issues of threading and process, and then which modules we have to create, which executable modules we have to create, and how they're deployed. It's a really wonderful way of thinking about the system. And one of the things that I noticed in the prior exams was that when we asked to have a UML diagram shown, people were sort of making up their own diagramming notation. I'd like you to be able to use standard notation for the process for illustrating use case diagrams, class diagrams, classes and associations, communication diagrams, and component diagrams. It isn't a lot, but it is diagramming that you're going to see over and over in a professional environment, and you should be able to create them accurately. And so we use that as a way of communicating a lot of our artifacts as we go along. It's how we communicate our use case models, how we communicate domain models, how we communicate state diagrams and state models. Because when we're building these models, the models themselves are abstract, but we use a diagrammatic notation to capture those, just like we use blueprints in a building. capturing the key elements of the architecture, and then progressively adding additional elements to the system. We do that as a way of reducing risk and being able to make sure that we have validated the requirements. In other words, making sure that we're building the right thing. And it allows us to incrementally test it, meaning verify the system. Are we building the right things correctly? So a lot of our discussion is focused on the notion of requirements. It turns out that while requirements can be a little bit tedious at times, it is an absolutely vital part of creating models of our systems. And you should be able to portray actors, use cases, the system boundary, and the relationships between them. And we do this as a way of capturing or enumerating the functional requirements of the system and understanding what's in the system and what's outside the system. The actors are typically the sources and the sinks of events, and we saw a number of ways of doing that. So you'll want to be able to look at your requirements document and produce use cases from them. I'm just going to that over. Hold on just a moment. There we go. We also talked about non-functional requirements, specifically performance and scalability, and the ability to understand where that fits in the architecture. We've spent a lot of time on testing, and this is one thing I'd like to underscore, and you should have a good feel for this and go back and review it if you haven't, and that is test plans are specifically the way we organize our tests. What aspect of the system is it that we're testing? What is it we hope to achieve with those tests? In other words, what are we hoping to validate and verify? What resources do we need to carry out the tests? And then test cases are specific tests that we run that we believe are demonstrations of the accuracy of the system. In other words, we're verifying the system. One of the mistakes I saw in the midterm exam quite a bit, and even in quizzes, is that test cases are not supposed to be vague. For example, if I'm testing withdrawals in my ATM, the test plan would be, I'm testing withdrawals. In other words, I'm not particularly interested in deposits or checking balances, etc. And I am going to do it. I need 3 test accounts. I need a bank simulator, for example, because I can't afford to run these tests against real banks. So I have a number of bank simulators that I can connect to. And then my test cases are specific tests where I can measure the results. So for example, a test case for an ATM withdrawal would be using Bob's account, which starts out at $100. I'm going to withdraw $40. I'm going to then verify that there's $60 in Bob's account. And that test either passes or it fails. Now, the different test cases should be designed to test primarily boundary value conditions. In other words, I'm going to test different classes of data, test data. For example, I might test for zero balance, a nominal balance, increments of 20, if I'm only going to be dispensing $20 bills, withdraw the entire amount, withdraw more than I have in it. So I'm looking at the different boundary values. You should be able, from a description of the system, create an accurate domain model that captures the various entities in that domain. Remember, you're not capturing processes in there for the most part, unless the process is a fixed and concrete abstraction in the environment. But in most of the cases we've looked at, that is not the case. So make sure that you're not confusing process with the entities in our domain model. You'll want to be able to show which abstractions exist, what their relationships are, and any multiplicities they have. using the appropriate UML icons and associations, because that demonstrates, A, that you can clearly communicate it, and that I can clearly understand your understanding of the domain model. Any questions so far? You should be able to see all of the, you should be able to see at this point the review guide and any questions that you might want to ask. Going back to the review guide, design patterns that we have looked at include the command pattern, the memento pattern, which deals with persistency. The model view controller pattern you will want to know well. In particular, you should be able to show that you understand the distribution of responsibilities in that, and that we saw that the model view controller pattern actually works at a number of different levels, ranging from the lower level code to basic system organization, all the way up to the highest system architecture level. And the publish, subscribe, or observer pattern as well, which is part of the model view controller pattern. Well, it's not functionally part, but it's found in that. Then you'll also want to remember the facade pattern, which is used to create interfaces to another object, and especially in one where you're creating a facade that's compatible with some other part of the system, and it hides the fact that a object or set of objects may present some other set of services. We've talked about persistency in particular, and if you recall when we talked about entity objects, when we were talking about the three different types of or categories of objects that we frequently find at the analysis level, we see that some are at the boundaries, some are controller type, and then there are these entity objects that tend to represent abstractions in the domain and often tend to be persistent across time, and that we frequently want to be able to map those onto either a database or be able to to express them in terms of a exchangeable format such as JSON or XML that can be sent to another process, and that the object becomes persistent enough that it can be passed between processes. Software architecture has been a prevalent, if you will, but we never sat down and talked about it explicitly, but we talk about it all along in the semester. And we talked about how software architecture describes the components of a system, their relationships, and their interactions. And we talked quite a bit about this notion of coupling and cohesion, where we are attempting to maximize cohesion and minimize coupling between the different elements of the system. And we looked at a couple of ways of dealing with complexity in our architecture. Specifically, we looked at layering and partitioning. And we did that as a way of breaking the system into understandable parts, where layering allowed us to organize the system from top to bottom in varying levels of abstraction. And I actually have a picture of that I was going to try and bring up the other night, last night, and had some difficulty finding it. And now I have it. And I'm going to share that with you. Go over and share. Layering example here. And here you should be able to see that we had, for example, some layers where we had low-level data, application that lies on top of it, a presentation layer that's on top of that, and then in one case, a presentation client or just a presentation layer. And then we also saw an example of partitioning, and that's this one over here, where we have flight planning, air traffic control, and flight plans. And here we've partitioned the system into several different components that have different major responsibilities. For example, flight planning in our air traffic control example did specifically planning of a flight from an origin to a destination and filed flight plans. Air traffic control references those flight plans, but is independent of the flight planning itself. There's a question here. It says, when we use terms business logic and business objects, what part of the 4+1 view do these items belong to? That's a good question, because when we tend to think of business logic, we're talking really, in many cases, there's two places they show up: in the use cases themselves, and also in the domain model. And that logic is typically expressed in either the way objects interact or in the constraints on the attributes of an object. And maybe a little bit more of an answer than you want, but you're typically going to find the business logic in those objects in the logical view of the system. When we then go to design the objects and actually build them, we're going to be creating a lower level design model that says, how do we take these rules and actually cast them into code? And which objects do we actually need to build in our system? So for the most part, they're found in the logical view of that 4+1 view, coupled with the use case model. I'll go back to my we talked about interfaces and protocols quite a bit. And one of the things that's important to remember about interfaces is that in larger systems, we tend to treat the objects or set of objects behind those interfaces as black boxes. In other words, we don't really know what's going on. And so we saw as an example with the compiler that one time, where the facade pattern is really a way of expressing that concept. And that is, we create an interface that says, these are the services, these are the operations I support, but I may have a number of objects behind me that actually do the work. But this is what you're going to interact with. These are the set of operations you can use to interact with me. And the interface is well defined in terms of not only what data goes in and out, but also the protocol, meaning what order do I have to do this in what states? In other words, what does the client of an interface have to do? We talked about extending interfaces rather than continually piling them up, and I believe I have a slide on that that I'd like to show. No, I don't. Not right at the moment. And in particular, that rather than changing an interface, we typically like to extend the interface and add additional behaviors. And I'm going to find that so that I can share that with you. Yes, there it is. No, that's not the one I want. One moment. There we go. Sorry about that. Show this one picture. So in this case, I'm extending the FTP interface, and that means that rather than adding in the ability to get multiple files with the FTP and changing that interface that has just list and get, I actually extend this or use it depending on the particular design scenario that I have. And so that means that FTP stays consistent, and I then extend it. So users might say, oh, well, if I'm actually using the one with multiple FTP, that's the class I'll use, and I get all the behaviors for it. And then okay, so go back to the so you should also know the role of HTML and CSS that we saw in the labs. I think that was pretty straightforward. And then the role of JSON, HTML, and CSS, that you're taking data that is in a persistent described form. In other words, the data is self-descriptive. HTML organizes the data, and then CSS styles that data. You should know how to deal with basic state models. A state model is the set of states, the transitions between those states, the events that cause those transitions. You don't need to know about guards, but if you're familiar with the garage door example that we did both in class and then in the lab, you should be pretty well prepared. So that if I give you a set of states and events, that you would be able to illustrate what happens in that state model. We've had a fair amount of focus on change management and configuration management and version control. We started out with this discussion of, as we are creating all of these artifacts in our system, we're doing work and we're creating outcomes. And in many cases, we're producing units of configuration. We're producing artifacts. And if you know, as we were jokingly saying, you can spell it with an E or an I. The artifacts can be code, they can be documents, they can be plans, and many of these are part of the configuration of the system, and we have to decide on that granularity. And we then also think about, well, what's getting changed as we move through the different iterations in the system? And then we start to think about what items are required for what build. So I'm just going to pop over to a diagram in the following. I was just going to open up the discussion on project management. Oh, here it is. It's going to share that for you. You'll remember that the outcomes themselves can be big or small. They can be individual work products, or they can be sets of work products. And the process themselves, work delivers outcomes. So outcome connected back to work over here. And that work is either a single task, usually assignable to one person, or an activity, which is a composite of tasks or other activities. So it will be useful if you remember these relationships, and that is that a project is a project is work, which is a set of tasks or activities that deliver outcomes. And those activities could be conceptual, they could be related to building software, or they could be activities related to delivery. And that activity could be either a single task or a group of tasks that compose an activity. Some of the activities could be different functions, like writing a requirement document or developing code. And all of those deliver some outcome. And it might be a single work product, like a Java file, or a set of work products like release documents and test plans, or deliverable code. And those are what we are managing in the software development activity. And we saw that these tasks have individual attributes, like a start date and an end date, how long they take, and then dependencies between them. So one of the things you'll want to be able to do is, one, think about when we have different versions of software. In other words, sometimes we, from a configuration management perspective, we will break a development path into two different branches, and that can be for a couple of different reasons. I might break it into a separate branch for purposes of and I'm just going to share that back again. For purposes of parallel development, and we might also break it because we have two different versions of the system, for example, for two different target environments. We have a question here. If we consider a JSON package to work with JSON objects that were given to us during the Chronotimer project, the archive can in fact be described as a component, because when we import it back in, it is individually deployable in that respect. says all import statements deal with components import, or it depends on the implementation. Well, in Java, the import statements are going to refer to specifically to, if I think I'm understanding your question correctly, the import in the source code is importing those into the compilation environment. But in the IDE, you can also be including other jar files that will be linked in, and those can be considered separate components as well. Just going back to my... then finally, with components, you should be able to understand what a component is. And I think that was part of the nature of that last question there. That the components typically provide some set of services, either at a low level, like an individual object level, or at high levels, like we saw. In terms of the 4+1 view, they are typically in the compilation and deployment activities. So we can build, as part of our development activities, we're building components, and often they're deployed into a runtime environment. And they have well-defined interfaces, like we saw with the chrono timer. And I'm just going to see if I can pull that up here. And I'm going to share that. Yes. You should be able to see that. We saw the notation for component interfaces. And the reason these were important, and this is the diagram that's probably the most important here, is it is a way of showing dependencies between the components and the interfaces that they provide. In this case, we had specific runtime components. We had three. We had the chrono timer program that we developed. We had the display portion of the system that we built and deployed in our server environment. And then the browser connects to that port. And we had two different interfaces to connect to. One for the display, where we sent the results, and the other one where we went and read the results. So we had two different interfaces that were available. And then we also saw an example of a slightly larger view. Let's see if I can make this big enough to make. And Zuora supplies the iManage interface. And then finally, let's see, I'm just going to go back to our study guide here. You'll want to know the UML notation for that. And working on it. Yeah, should be able to see that. And let's see. Oh, one other quick thing. You should read through the requirements. It just gives you a little bit more time. And as you're going back and revisiting some of the things tonight, keep that in mind, and you can sort of use that as a way of saying, can I I'm back. Okay. Sorry. Lost the connection there for a moment. I'm just going to take you back to this. There we go. You should be able to think about that set of requirements in the context of some of these things we've talked about. Testing, in other words, specifically being able to think about requirements, use cases, domain model, test plans, test cases, the components within that. So that's sort of how you're going to want to be thinking about those requirements. Now, you can't bring in your own copy, but I will have a printed copy available for you in the test. But if you read through it and sort of think through it a little bit better, that makes it a little bit easier, so you're not trying to sort of quickly read through that. I know in my case, I'm often a slow reader. I start reading it and then suddenly I'm thinking about, I don't know, airplanes or airspaces or something else, and get lost in it. Be sure to bring a pencil or two. I'll have some scrap paper there, and we're going to be let's see, we have one other question here. In the slides file for the services lecture, service described is as an industrial strength object. What is that exactly? When I said that, I was sort of, it wasn't a literal term, but what we're saying is that rather than just an object that exists within an address space, that object is kind of like the component that we did for the race display. It provides an external interface that can be linked to by other programs or processes, that the interface is discoverable, and that the interface is public and well-defined. So in other words, it's very much like an object in that an object encapsulates data and behavior and presents a well-defined interface. And when we talk about objects, we often tend to think of them as Java-style objects at runtime within a single address space. But we can also have much larger objects that exist at runtime as a whole process that has a well-defined interface and encapsulates data within that. So when we tend to think about enterprise services like that, these are behaviors that are presented at a high level. They represent business type behaviors, typically some business value, and they are frequently discoverable in some automated way, and I can connect to them often at runtime, but I can usually connect to them dynamically. Remember that that the exam is at 7:30 tomorrow, 7:30 a.m., and it is in B56, and will last for 2 hours. It should take you, I'm guessing, about an hour and 20 minutes to do the exam, so you should have plenty of time to look over your answers and to write legibly. So great. I will see you tomorrow morning, bright and early, and we'll take this to a final wrap. Have a good evening.